Hi everyone, today we'll take a look at properties of modulus functions. In addition, we'll also look at a few domain-related questions which include modulus functions. Alright, so this video is going to be a very short one. I'm going to discuss a couple of properties, right? Modulus functions don't have a lot of significant properties. You just need to be aware of them. So they just essentially will help you in solving questions a little bit more quicker and easier. Right, so let's get started. So property number one, right? So property one. All right, so property one is like this: modulus of a times b is equal to modulus of a times modulus of b. You can always break things apart like this. All right, you can always. So you can basically I can say is what I can say is, in general, right? In general, basically I can say is a1 times a2 times a3 dot, right? I can be multiple, different constants or variables inside, right? All the way to the nth term, right, is equal to a1 times a2 times a3 all the way down to modulus of an. Okay, so that's how it is. All right, so if I want to give you guys an example, right, if I want to take an example, I can say, if I say a is equal to 2 and b is equal to -3, I can say, modulus of 2 times -3 is equal to modulus of 2, right? Modulus of 2 times modulus of -3, right? So this is going to be modulus of -6. This is 2 times -3. So this is 6. This is 2 times 3, which is also 6. So this works out. All right, so let me change the color. Now let's look at, property number 2. Okay, so let me make some room here, and I'll say property 2. Okay, so in property 2, it is basically a times b, and whole inside the modulus is equal to modulus of a upon modulus of b. Right, very simple, nothing straightforward. I'm just telling you these, so maybe if you ever have a function like x minus 3 upon 4x minus 1, and you have it all upon one modulus, you can always break them apart. Okay, you can always write them as modulus of x minus 3 times upon modulus of 4x minus 1, like this. This is the whole purpose of me telling you. So when you see something like this and you're finding difficulty in moving forward, this is when you can use these properties to make your life easier. So an example I can give you is, if a is equal to 2 and b is equal to -3, I can say 2 times -3 is equal to modulus of 2 times modulus of -3. So this would be 2/3, and this would also be 2/3. So you can see how it goes, right? Okay, so now let's look at a property called the triangle inequality. All right, so I'll take it here. It's a fairly small one, and I don't really necessarily remember using this property anytime, but it's good to be aware of it. Okay, so I'll say property 3. Okay, so the property 3 is a very simple one. It says modulus of a plus b is always less than or equal to modulus of a plus modulus of b, right? It can be less than or equal to, right? So that this is the whole principle behind it, right? So again, I can, if I want to generalize it, I can also say, a1 plus a2 plus a3 all the way to an, right? Like this is less than or equal to a1 plus a2 plus a3 all the way down to an. All right, so if you want to take an example, you can always, take an example, right? It's not a huge deal. Okay, so if I want to take, again, I want to take a is equal to 2 and b is equal to -3, so I can say, 2 plus -3, right, is going to be less than or equal to 2 and then modulus of -3. So I'm going to have, this is going to be 1, right? So this is going to be 1 is less than 2 plus 3, which is 5, right? This is always going to be 5, right? And this will be less than. So this works also, right? Now the converse of property 3 is, again, it's gonna be quite similar. So I'll change the color again, and I'll say property 4. So property 4 is like this. So A minus B, right, is greater than or equal to modulus of A minus modulus of B. It's like this. All right. You can, it's almost like the inverse of what I just explained right now, right? That's all it is. So this is like, you can also think of this as the upper bound. Sorry, the lower bound, right? The lower bound. And you can consider this as the upper bound, right? This is the maximum value you can have, and this is the lowest value you can have, right? So you might experience this maybe in complex numbers, in particular, right? When you have to find lower bound or upper bound of complex numbers. I'm 90% sure you will not have it. Maybe you might have it in paper. That's a pretty high possibility. A question like this, where you're supposed to find lower bound or upper bound of complex numbers, right? That's a possibility. But otherwise, I don't think you can have it in your normal paper 1 and paper 2. So again, if I want to generalize this, I can have a1 minus a2 minus a3 all the way down to an. This is greater than or equal to big modulus, and then I'm going to have individual moduli again. So I'm going to have you know a1 minus a2 minus a3 minus, and then an, like this. So yeah, again, I can take two numbers. Again, I can take a as 2 and b as -3. All right. So if I do that, I'm going to have 2 minus -3, right? So it'll be greater than or equal to modulus, right? Modulus of basically this one. So it's going to be 2 minus -3, right? Like this. So there's going to be 5, right? And then I'm going to have 2 minus modulus of 3 is just 3. So I'm going to have it like this. This is going to be -1, but it's modulus. So it's going to be 1. It's going to be 5. So 5 is greater than or equal to 1. So this is true. So this works as well, right? So these are the 4 main properties you need to be aware of in with respect to with respect to the properties of modulus functions. All right. So now let's take a look at domain related questions. In this question, we have to find the domain of f of x. So the key point here is to understand that there are 2 functions. We have the radical function and the modulus function. All right. So first we have to satisfy the conditions of the radical function. Once we've done that, then we can move on and satisfy the conditions for the modulus function. All right. So let's change the color to red. All right. So to satisfy the conditions for the radical function, we must say that whatever inside the square root, right, must be greater than or equal to 0. So that's the first thing we're going to do. We're going to say 1 minus modulus of x minus 1 all upon x plus 2, right, is greater than or equal to 0. All right, that's the first thing we're going to do, right? So when we do that, right, we need to, now we can split the 2 cases, right? We're going to have, because we know x minus 1 is the only thing inside the modulus. So x equal to 1 is going to be that breaking point where we're going to experience some, turn or like a corner, right? It's going to be like a vertex of a polygon, right? So now I can take 2 cases. I can take case 1, right, which is what I'm going to do starting off. So case 1, right, is going to be when x is greater than or equal to 1, right? So when I do that, I'm going to have something like this. So I'm going to have 1 minus x minus 1 times, upon x plus 2 is greater than or equal to 0. All right. Now I can take the least common denominator. So I'm going to have x plus 2, right? I'm going to have x plus 2 minus x plus 1 all upon x plus 2 and greater than 0, right? Simplifying this a bit more, I'll do it right here, right? So I'm going to have 3 upon x plus 2 is greater than or equal to 0, right? So I can clearly tell that whenever x is going to be greater than -2, my function is going to be positive. That's going to be positive all the time. So I just have to see whenever x plus 2 is going to be positive. So it's going to be basically like this. So I'm going to have x is greater than or equal to -2, right? So I can say, from right here, right, x has got to be, so therefore x is going to be greater than or equal to -2, right here, like this, right? So I have one part done, right? And I also know that x has got to be greater than 1, right? So I also have this, right? Let me, put a box around this as well. So this is the first case. So now if I'm going to take a number line, right? If I take a number line like this, I'm going to have -2, -1, 0, and 1, like this. So I know it's got to be greater than or equal to -2. So it's going to be like this. Sorry. It's going to be something like this. And it's going to be like this. So as a matter of fact, it's got to be, x has to belong from 1 to infinity, right? That's how it's got to be. That's how it's got to be. So this is the first part, which is what we have. I'm going to start this because this is the important part. Now let's look at case 2, right? So I'll change the color. I'll take it to orange, right? So I'll take case 2 down here on the next page. I'm going to have case 2 like this. So case 2 will be when x is less than 1, right? So now when I have basically when x is less than 1, I'm going to have 1 plus, right? Sorry, let me read this. It's too far away. So 1 plus x minus 1, right? I just reversed the sign. So signs of both, right? So I'm going to have 1 plus. So this was a minus sign right here. I put a plus sign right there instead, right? So 1 plus x plus 2 is greater than or equal to 0. All right. Take the least common denominator, x plus 2 plus x minus 1 all upon x plus 2, which is greater than or equal to 0. Right. So this is going to be 2x plus 1, right? So 2x plus 1 all upon x plus 2 is greater than or equal to 0. This, right? So now the range for this, right? So the range for this is going to be, it's got to be greater than or equal to, sorry, it's going to be less than or equal to -2, right? So what I'm going to do is I'm going to draw a number line first of all, right? To make everything more simpler, I'm going to draw a number line this. So 1 is going to be at, -2. 1's going to be at -half, something like that, right? And yeah, and it's going to be, and I also need to have 1 right here because we're taking this into account as well, right? So like this, right? So first thing I know is that this has got to be this way, right? So whatever, anything going to be less, x has to be less than 1 in case 2, right? That's the first part. Then I know that these two must be the same sign all the time, right? So let's take a number, right? For example, let's take -10, right? So -10 right here would be negative, and it would also be negative here. So this part is positive, right? This part is positive. So this part is negative and this part is positive. So this works kind of like this, and this works kind of like this. So the common region we have here is basically -2, right? So I can rewrite it in proper terms. So I'm gonna have x belongs to, right, -infinity to -2, right? Union 1/2 to 1, like this. Something like that, right? 1/2 to 1. Sorry, -1/2 to 1, right? So this and this, and sorry, this, right? All of this, and let me scroll up, sorry, I didn't scroll up before, and this satisfy, my condition, right? So these are our acceptable values of x, right? Like this. Let me redraw the square. And this, right? So these are my acceptable values of x, right? Let me see if I can, create any common ranges between them, right? So that was right here. So x was from 1 to infinity, and this was from negative infinity to -2, and yeah. All right. So what I can do is I can simplify this, right? If I want to, if these are the two possible ranges, what I can do is I can find one. I can write the domain, right? The domain or the range of x, right? In one simple form, and that what I'm going to do is I'm going to take both cases into consideration. Okay. So I'm going to say that this is okay, right? -2 to infinity, not inclusive, right? So -2 to negative infinity, not inclusive. Union. So this is from -half to 1, and this is from 1 to infinity, right? 1 inclusive. So I can write this as -half to infinity, right? That's what I'm going to do. So I'm going to have -half to infinity. So this, right? So this will be my final domain, right, of my question. All right, so this question is quite similar to the previous question, right? So we're going to start with the same part, right? We have to satisfy the conditions for the radical function first. So for that, we have to say that basically. Let me change the color. So I'll say take green here. So I'll say 2x minus 1 upon x squared minus 1 with the modulus all around. Minus 1 should be greater than or equal to 0, like this, right? So now I'm going to take the plus 1 to the other side, so I'm going to have 2x minus 1 upon x squared minus 1 is greater than or equal to 1, like this, right? Pretty simple. Okay, so now I'm going to take two cases, right? So I'm going to have case 1 here. I'll scroll down a bit. So I'll say case 1, right? So case 1 right here. So case 1 will be when I have 2x minus 1 upon x squared minus 1, and it says it's just greater than or equal to 1, and I'm gonna have case 2 right here. Case 2 is 2x minus 1 upon x squared minus 1, which is less than or equal to -1. Now, if you're confused about how I'm doing this so quickly without even thinking twice, you can look at my previous video where I actually solve loads of these questions, right? Of modulus equations and inequalities. And I told you a special trick. When you have modulus of f of x greater than or equal to a, you do certain things, and when you have less than equal to a, you do certain things, right? I'm not going to explain them again because I've already done the same things before as well, right? The only change up in this question is the fact that you have a radical function. You have to take care of certain things as well, right? So now we have this. Now we have the two cases. So now all I have to do is I just have to break them apart, and solve them. So I'm going to have 2x minus 1 is greater than or equal to x squared minus 1, right? Like this. Okay, so again, either I can do this. So now what I'm going to have, I can do this, or, right, or what I can do is something different. I'm going to show you that. This is something you can do on your own, right? I don't even need to tell you much about this, right? The only difficulty that I see, maybe you might face, or you know what, I can go ahead and do it, right? So I'm going to show you both ways what I was thinking. So it's going to be x squared minus 1, like this. These two cancel off. So you're going to have x squared minus 2x, right? If I take it to the side, is going to be less than or equal to 0, right? So you're going to have x times x minus 2 is less than or equal to 0. So I'm going to have to make a number line now, right? I'm going to have to make a number line. So I'm going to have 0 and 2 right here. So if I take 1, right? So 1 is going to be positive. This is going to be negative. So it's going to be positive and it's going to be positive. So I can say that basically my x has to be between 0x and 0 and 2 inclusive. Something like this, right? However, this won't satisfy all the possible values. So what I'm going to do is I'm going to stop right here. I'm going to erase all of this, okay? And I'm going to show you how the proper method to do it because it's a radical function, right? I'm going to miss out on certain things, okay? So what I'm going to do is I'm going to subtract 1 on both sides. So I'm going to get 2x minus 1, right? 2x minus 1 upon x squared minus 1, right? Like this, 2x minus 1 upon x squared minus 1. Minus 1 is greater than or equal to 0, right? Once I've done that, I'm going to take the least common denominator. So I'm going to have 2x squared minus 1 minus x squared plus 1 all upon x squared minus 1, which is going to be greater than or equal to 0, right? I'm going to create a division here like this, right? Like this. Okay, so now I'm going to have 2x squared minus x squared, right? So I'm gonna change the sign and multiply both sides by -1. So I'm gonna have x squared minus 2x upon x squared minus 1, and it's gonna be less than or equal to 0, right? So I've skipped a few steps, but I'm pretty sure, I'm confident that you can figure out what I've done here, right? So I'm gonna have x times x minus 2 and x plus 1 times x minus 1 less than or equal to 0. So these are the few things that you were missing, right? So let me just create a better line right here. Okay, so I'll do this like this. All right, so now I'm going to take all the possible, I'm going to take all the critical points. So I'm going to have x equal to 0, 2, 1, and -1, right? Draw a number line like this. So I'm going to have -1, 0, 1, and 2, right? So if I take a look closely, right, I'm going to take a look, maybe I'm going to take some value like 10, right? So 10, positive, 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 and positive. So this region is going to be positive, okay? If I take any value right here, right, so this is going to be positive, this is going to be negative, this is going to be positive, and this is going to be positive. So it's going to be negative, right here. This part is going to be negative, right? If I take any value between right here, so this is going to be this is going to be positive, this is going to be negative, this is going to be negative, and it's going to be positive. So I'll have negative, negative, go to positive right here, right? Similarly, between 0 and -1, I'm going to have another negative region and a positive region right here. So I want this to be negative, so basically I can say x belongs to, right, -1 to 0, right, union 1 to 2, like this, right? So this is my first range that I have, right? Let me create further line that goes this, perfect. So I can work on case 2 now, right? Same thing I'm going to do for case 2. Literally nothing's going to be different for case 2, okay? So I'm going to add 1 to both sides. So I'm going to have 2x plus 1, sorry, 2x minus 1 upon x squared minus 1 plus 1 is going to be less than or equal to 0, right? This is going to go up, so 2x minus 1 plus x squared minus 1 all upon x squared minus 1 less than or equal to 0, all right? So now I'm going to have x squared plus 2x minus 2, all right? So I'm going to have x squared plus 2x minus 2 all upon x squared minus 1, right? X squared minus 1. All right, that's what I'm going to have. So now like this, I'm going to have less than or equal to 0. Now I can't make a factor out of this, right? It's kind of difficult situation. So what I'm going to do is I'm going to add a plus 1 and subtract 1 right here. So I'm going to do plus minus 1. That's going to give me x squared plus 2x plus 1, right? Sorry, I'm going to take a minus 1 here. Sorry, I'm going to take a plus 1 here off this. I'm going to give a minus 1 there. So I'm going to have x squared plus 2x plus 1 minus 3 all upon x squared minus 1 less than or equal to 0, like this. So this is going to be x plus 1 whole squared minus root 3 whole squared, right? This is a tricky part, right? If you've seen this for the first time, it's okay, right? But you can expect something like this for sure, definitely, right? So I'm gonna have something like this now. Now you can see this is the form of a squared minus b squared form, right? So there I'm gonna create a factor, right? So I'm gonna say x plus 1 plus root 3, right? And then x plus 1 minus root 3. And obviously I'm gonna have x plus 1 times x minus 1 less than or equal to 0, right? So now let me create my number line again, right? So I'm gonna have my number line like this, like this. So I'm going to have -1 minus -3, right? So -1 minus square root of 3, and then I'm going to have -1 plus square root of 3 also, right? So -1 plus square root of 3 is going to go somewhere right here. -1 plus square root of 3 is going to be less than 1 for sure. And I'm going to have -1 here, right? And then I'm going to have, I think 0 is going to be somewhere here as well, right? So 0 is going to be here somewhere. Right. So now, if I take different values, what I'm going to get is I'm going to get positive, negative, positive, negative, positive, negative. All right. So this also has to be less than 0. So my x, right? So the values of x that I can take is basically inclusive -1 minus 3, 2, 1, union, it's going to be, so let me just make this part clear a little bit. I haven't, okay, so I didn't make a small mistake. So this is going to be positive entirely. And then because I put a zero there, then it's kind of confusing. So it's going to be like this. Wait a second. So yeah, plus. All right. So it's going to be -1 plus √3 all the way to 1, like this, right? And just want to make something clear. So it's not going to be inclusive of 1, right? It's not going to be inclusive of 1. They're going to be, parentheses around. So, okay, let me just do this here. So, right. Okay, so let me just see if I've made any mistake anywhere. I don't think I have. I don't think, I think square brackets are fine here, right? Because everything was in terms of less than or equal to. So we can put square brackets here. Now it's a little complicated, so I'm just going to leave it at this, right? I can, so this is going to be one acceptable val. These are going to be one range of acceptable values of x, and this is going to be another range. So all of these values are acceptable, right? So this works and this works. All right. So this was a final question. So we did 2 questions and a loads of different properties in today's video lecture. Okay, so next video or next couple of videos, tutorial videos, we're going to take a look at logarithmic functions. After logarithmic functions, we're going to take a look at properties such as even and odd functions. Okay, and we'll also take a look at them again when we do trigonometry. Okay, so then we're going to take a look at composite functions and function transformation. So horizontal, dilation, vertical dilation, horizontal and vertical translation, all of those sorts of things. All right, so this was all for today's tutorial video, and I'll see you in the next one. Bye bye.